So in this video, we're going to do conversions from polar coordinates to rectangular coordinates. So if P is a point with polar coordinates r comma theta, then the rectangular coordinates xy of P are given by x equals r cosine theta and y equals r sine theta. Now, why is this true? Well, if we draw a point in the xy plane, so we go over some x distance and up some y distance, that's x comma y. To get the distance r between those 2 points, the pole and the point P, well, this is Pythagorean Theorem. So r squared equals x squared plus y squared. And to get r, we take the square root of both sides. So r equals square root of x squared plus y squared. Okay. If I look at this, I can use trigonometry. Theta, the sine of theta is equal to y divided by r. So to solve for y, to get the y value, I multiply both sides by r. The cosine of theta is equal to x divided by r, adjacent over hypotenuse. So to get x by itself, I multiply both sides by r. Thus, these formulas right here to get x and y. Now, this is for r positive. So that's for r positive. If r is negative and theta is in radians, okay, then r comma theta can be represented by negative r pi plus theta, okay? And if r is less than 0, negative r is greater than 0, okay? So that becomes positive now. And so now what do I have? I have the cosine of pi plus theta equals x over negative r, okay? And if I multiply through, I get, well, what is this going to be? This is actually equal to negative cosine theta, x over negative r. So x is still r cosine theta, which checks out. That's what we wanted. And then sine pi theta, pi plus theta, equals y over negative r. And this becomes negative sine of theta equals y over negative r. Multiply through by negative r, I get r sine theta. The negatives cancel each other out, and I still get the same answer. So even if r is negative, we're good. Okay, so we're still good even when r is negative. Okay? So let's do an example where I convert. Uh-oh. What's going on here? Are we locked up? Let me get out of this. Come back in. Okay, I'm going to clear it out and come back in and see if that'll fix it. All right, there we go. So I want to find the rectangular coordinates of the points with the following polar coordinates. Okay. So 6 comma pi over 6. So how am I going to handle this problem right here? Okay. So I have x equals r cosine theta, and I have y equals r sine theta. Now, what information do I have here? On the terminal, on my polar axis, I rotate up pi over 6, and I go out some distance of 6, and so that's my point, 6 comma pi over 6. Okay. So, this is in the first quadrant, right? So what does that tell me? That tells me that x and y are both positive. Okay, so if I'm going to convert this to the xy, so if I do an xy coordinate, those are both positive. All right. If I throw in r is 6 cosine of pi over 6. What is this equal to? Let me move this down a little bit. This gets me 6 times square root of 3 over 2, which equals 3 square root 3. And then this one gets me 6 sine pi over 6, which is 6 times 1/2, which is 3. So the xy coordinate is equal to 3 square root 3, comma 3. Okay? Now, the next problem, I've got the point -4 and negative pi over 4. Okay? So with this problem, start with my terminal axis. So I got my polar axis here, and I'm going to rotate negative pi over 4, so that's clockwise, rotate it down, negative pi over 4. But then my point is going to be not positive 4, but actually negative 4. So I'm going to move this a little bit so that I can get it all to fit. So it's actually heading out over here. So this would be the point -4, comma negative pi over 4. So what quadrant is this in? This looks like it's in quadrant 2. Okay, so that's in quadrant 2 right there. So I know that x is less than 0 and y is greater than 0 in quadrant 2. So my xy, this is a negative number and this is a positive number. So now all I need to do is run through the formula. X equals r cosine theta. So r here is -4, and cosine of negative pi over 4. Well, what do I know about cosine of negative pi over 4? That's equal to the cosine of pi over 4, even property. So this is -4 times square root 2 over 2. So that's -2 square root 2 for that x value. Now, y equals r sine theta. What does that get me? That's -4 times the sine of negative pi over 4. Since sine is odd, this is -4 times negative sine of pi over 4. So a negative times a negative makes a positive, so that's 4 times square root 2 over 2, which gives me 2 square root 2. So my xy coordinate is -2 square root 2, comma 2 square root 2. So that's conversion from polar into rectangular. So polar to rectangular. So the key here are the equations x equals r cosine theta and y equals r sine theta. Those are the keys to being able to do that.